Newton's third law of motion is also known as the law of action-reaction. People say that it should have been the first law, to come before the first law, so it should have been the zero law. But anyway, we will know it as the third law. So it states that for every force acted by a first body on a second body, and for example here we brought first bodies and second bodies, so for every force acted by a first body on a second body, there will always be an equal and oppositely directed force reacted by the second body on the first. Let us look at this. If a first body wants to act the force on the second body, in other words, push it to the right, much like this, then we can represent that action force with an arrow that is acting from the first body onto the second body. It will therefore be represented in a free body force diagram of the second body. The action force was acted on it by the first body on the second body. Newton's law therefore states that there will be an equal and oppositely directed force reacted by the second body on the first. So there will be a reaction force which is equal in size, there we go, and opposite in direction, acting on the first body. So a free body force diagram of the first body would look like this. So while the action force influences the second body, the reaction force influences the motion of the first body. This is an example of Newton's third law. The two forces are equal in size, they are opposite in direction, and they act on two different bodies. We usually show the bodies like this. The action force pushes the second body, the reaction force pushes the first body. So let's look at another example of an action force. If the action force was a push of me on the wall, so I push the wall with a force in a particular direction, let's say horizontal, with a size of 5 newtons towards the right. So I'm pushing the wall towards the right with 5 newtons. There are two bodies here. The first body is I, and the second body is the wall. I and the wall. So if I push the wall, then the wall will push me. And if I push the wall with 5 newtons, then the wall will push me with an equal size force of also 5 newtons. And if I push the body towards the right, then the body will push me with that force in the opposite direction towards the left. So if the action force is I push the wall, then the reaction force is the wall pushes me. So if I push the wall with a horizontal force of 5 newtons towards the right, the wall pushes me with a horizontal force of 5 newtons towards the left. This is an example of Newton's third law. The forces are equal in size, however, they're not acting on the same body, so they cannot balance each other out. Now let us consider a parachutist falling at constant speed, so that the gravitational force acting downwards is balanced by the air resistance force acting upwards. Newton's first law states that it will move at constant speed. Are these two forces that are equal in size and exactly opposite in direction an example of Newton's third law of motion? The answer is no. And the reason for that is simple. The two forces are acting exactly on the same body. There is no action-reaction here. That lends a second problem, because Newton's third law states that no force can act on its own. Whenever there is an action force, there is always an equal and opposite reaction force. So, in this case, can we say that Newton's second law is broken because only the gravitational force acts on the on the parachutist? No. So basically, Newton's third law states that Forces act in pairs. Whenever there is an action force, there's always an equal and opposite reaction force. In this case, the gravitational force means that the Earth pulls the parachutist with a vertical force of 500 newtons, let's say, downwards. The Newton's third law pair to this force would be the parachutist pulls the Earth with a vertical force of 500 newtons upwards. So when the Earth pulls the parachutist also pulls the Earth with a force equal in size and exactly opposite in direction. There is also a Newton's third law pair to the air resistance force. The air resistance force is the air pushing the parachutist upwards. But it's logical to understand that if the parachutist falls downwards through the air, it needs to push the air out of the way so that it can move down. Therefore, the Newton's third law pair to this force is an equal and opposite force that the parachutist acts on the air. That is Newton's third law.